order to perform the thermal buckling analysis on this bimorph, I have opened Ansys Workbench. Now what I am going to do is I am going to go to the file and I am going to restore the archive in which I have saved this thermostructural analysis of the bimorph, which I have done earlier in this particular course and saved. So I am going to press on restore archive, and it is asking me where the archive is present, and I am going to select this particular bimorph archive, and I am going to press open. And once I ask it to open, it will ask me the location where I can save the extracted files from that archive file. So I'm going to select this desktop, and I'm going to save it on my desktop. And once I save this particular files, Ansys Workbench will open all the archive files. Once the Workbench has opened all the files, then what I'm going to do is I'm going to perform thermal buckling analysis now. So you just need to go to this eigenvalue buckling analysis, drag and drop it onto the solutions branch of the static structural analysis system. So what happens here? This particular thermal loads have been transferred to the static structural, and in the static structural we haven't added any structural loads. So what happens, whatever the stresses and strains that are produced inside this particular body are due to the temperature differences or the temperature loads present inside this particular body. So what happens now, I am going to transfer the same loads to the eigenvalue buckling analysis system, and I want to find out the critical temperature or perform the thermal buckling analysis. Once I have transferred all the data, I am going to just double click on the setup cell in order to open Ansys Mechanical. So once the Ansys Mechanical has opened, see, we have access to the three systems which are present in the coupled analysis. We have both steady state thermal analysis, static structural analysis, and the eigenvalue buckling analysis. So now what I need to do is I just need to say solve everything. So I'm going to just click on static structural, and I'm going to click on eigenvalue buckling also, and I'm going to solve this particular problem. So now the solution is done, and I am going to click on this solution branch, and here I am able to see these load multipliers, and here also I have got one negative load multiplier as well as one positive load multiplier. So what happens here, the stresses and strains are only due to the temperatures that we have applied and the internal heat generation we have applied. So what happens, these temperatures are the boundary conditions, and this is the body conditions. In order to find out the buckling heat generation, you need to multiply this particular load factor which you have obtained here with this particular internal heat generation, so that you are going to get a value of internal heat generation at which the buckling of this particular bimorph occurs. So what happens, if you are going to perform a structural buckling analysis, you need to perform a static structural analysis in which you are going to apply all the required loads and then solve the static structural analysis, and then take this total results into eigenvalue buckling analysis and find out eigenvalue buckling. So coming to the thermal based buckling analysis, what you need to do is, first of all, you need to perform the thermal analysis, and then you need to transfer this particular loads into static structural, and from there you need to attach the buckling analysis system, and you need to perform the thermal buckling analysis. That is one thing. And another thing is, you can directly apply some thermal loads inside static structural analysis, and then you can convert, then you can take all these values into buckling analysis system to find out the buckling modes inside eigenvalue buckling. So with this, we have successfully finished our course, and thank you for joining me in my course.